Welcome back to Chemaleap. Software engineering is going through an absolutely massive shift right now. We're moving from writing strict syntax to just expressing intent, a concept we call vibe coding. Basically, you tell an AI what you want and it builds it. But let's have a reality check here. A raw large language model isn't actually an agent. It's really just an engine block sitting on a garage floor. It's incredibly powerful for sure, but to put it on the road safely, you have to build the chassis, the steering, and the brakes around it. So today, in this explainer, we're building that enterprise-ready security harness and evaluation framework so you can actually deploy vibe-coded agents in production with confidence.
And that brings us to a really massive challenge. Seriously, think about this. How do you secure a workforce that dynamically writes and executes its own code? Traditional security models were built for deterministic software, right? You write the code, it compiles, the tests pass, and it gets deployed. Boom, done. But vibe-coded agents? They operate dynamically. They're non-deterministic. They'll read error logs, rewrite their own logic on the fly, and autonomously decide which internal tools they want to call. We're no longer just securing an application. We're essentially securing a non-human entity that has the ambient agency to completely modify your production environments.
Okay, let's dive into this. Here is our roadmap for today's explainer. First, why vibe coding changes security. Second, the 7-pillar architecture. Third, sandboxing and identity. Fourth, agentic SecOps. And finally, evaluating agents. Let's jump right in.
Kicking things off with Section 1, why vibe coding changes security and trust.
So when we transition from verifying static, predictable code syntax to evaluating fuzzy, natural language intent, the old ways of establishing trust literally just stop working. Static credentials, like your standard role-based access control, or RBAC, act as a totally inadequate perimeter for autonomous systems. Let's be real. In an agentic system, your AI might possess a perfectly valid access token, but it could be operating with completely misaligned or even compromised intent. That's exactly why we have to move to a context as a perimeter model. Trust can't just be a gate you pass through once during deployment. It has to be dynamically verified at runtime, what we call continuous effective trust. We need to constantly evaluate the agent's behavior, its supply chain, and its context to make absolutely sure it hasn't been hijacked.
Moving on to Section 2, the 7-pillar security architecture for agents.
To safely host any autonomous system, we desperately need a layered, defense-in-depth approach. At the foundational level, we have the agent security pillars. This is your mandatory baseline, built on the assumption that the underlying AI model might fail or get exploited. And then layered right on top of that, we extend into the high-velocity code execution controls and the active agentic defense mechanisms. This separation is absolutely vital. You simply cannot build active defenses if your underlying infrastructure is full of holes.
Let's rapidly break these 7 pillars down. First, infrastructure. This requires ephemeral, kernel-level sandboxing. Think gvisor. Second, data. You need strict tenant partitioning. Third, model prompts. Treat these as sensitive, cryptographically signed artifacts. Fourth, runtime. You need LLM firewalls to intercept dynamic prompt injections. Fifth, IAM. Assign unique agent identities to prevent privilege escalation. Sixth, observability. Continuously track the agent's internal reasoning. And seventh, governance. Ensure every single automated action traces right back to a human audit trail.
All right, Section 3, guardrails, sandboxing, policy, and identity boundaries. Now, let's talk about the absolute chaos of real-world development.
We have to talk about a uniquely modern supply chain threat called slop squatting. This is wild. Large language models frequently hallucinate software packages that literally don't exist. Well, attackers know this. They actively monitor developer forms for these hallucinated names, and then they proactively publish malware to public repositories using those exact fake names. Because an autonomous agent can alter dependency graphs and download packages all on its own, a single hallucination can pull malware straight into your build environment. No way, right? To defend against this, you must force agents to source dependencies exclusively from vetted internal enterprise registries, strictly verify your software bill of materials, and enforce binary authorization. Another huge risk is MCP spoofing. Agents today use frameworks like the Model Context Protocol to dynamically discover and connect to your enterprise tools. The massive danger here is that a compromised server can pose as a legitimate internal tool, injecting malicious payloads or demanding crazy levels of privilege. To stop this dead in its tracks, you have to route all agent-to-tool connections through a centralized agent gateway that enforces strict contextual authorization, verifying that the tool call perfectly aligns with what the developer actually intended. But hey, even with gateways, we face the classic confused deputy problem, just on steroids. Imagine a developer unknowingly pastes a snippet from a poisoned open-source repo into their IDE. That snippet contains invisible payloads carrying hidden prompt injections. The developer's agent reads the context, gets completely tricked, and executes an unauthorized command on the attacker's behalf using the developer's massive admin privileges. To stop this, an agent must never, ever operate using the human's broad credentials. It desperately needs its own uniquely identifiable agentic identity.
Which leaves us directly to enforcing zero ambient authority. Look, if you have admin rights to the production database, your coding assistant shouldn't have them by default. Instead, we have to use just-in-time downscoping. When an agent spins up to write a script, it should receive fresh, hyper-restricted credentials and file tree allow lists, scoped only to the exact data required for that one single task. And the second that task concludes, those credentials instantly expire.
Let's see how this actually applies to high-stakes actions, like modifying that production database. We can't just rely on simple approve or deny pop-ups, because let's face it, developers will blindly approve 600 lines of generated code they don't even understand. Instead, we require a three-step elicitation process. First, the agent must actively request confirmation. Second, we mandate hardware cryptographic MFA. Third, and this is the real game changer, we present the vibe diff. We intercept the complex code and translate it back into a plain English summary. That way, the developer reads exactly how their fuzzy intent maps to the proposed execution before they ever hit consent.
Next up, Section 4, Agentic SecOps, Red Team Agents and Runtime Analytics.
Because vibe-coded logic is generated at just unprecedented speeds, humans simply cannot review code fast enough anymore. To secure autonomous AI systems, your security operations literally have to become AI-driven themselves. We do this by deploying an autonomous SecOps triad. First, the red team acts as the agent attacker, dynamically injecting adversarial vibes to see if your agent hallucinates an insecure solution. Second, the blue team is your agent defender. It continuously monitors the runtime agent bill of materials, tracking every single tool and dataset the agent touches in milliseconds. Third, the green team is the agent fixer. If a vulnerability is found, it executes stateful quarantines and autonomously refactors the insecure code.
Now, the blue team's absolute most critical job is monitoring for intent drift and trust decay. In vibe coding, a super simple prompt to optimize the database query might maliciously drift if the agent's internal chain of thought suddenly decides to download some unauthorized external indexing library. When the execution trajectory diverges from the human's original vibe, trust decays. The system detects this anomaly and triggers stateful circuit breakers, instantly rolling back the environment to a safe version control checkpoint and revoking access.
And without rapid circuit breaking, you are totally vulnerable to a devastating AI threat, denial of wallet attacks. Imagine waking up to a $100,000 cloud bill because an attacker trapped your agent in an infinite API loop. Ouch. And in an agentic system, adversaries use hidden prompt injections to intentionally trap your agent in a computationally expensive reasoning cycle. The agent just keeps thinking, calling tools, and burning tokens in the background until your cloud accounts are completely bankrupt.
Finally, Section 5, Evaluating Vibe-Coded Agents Beyond Tests.
So we've successfully secured the boundary, ensuring the agent didn't do anything malicious. Awesome. Now we open the glass box. This quote really hits the nail on the head. Generation is a solved problem. Verification, security, and architectural judgment are the new craft. Writing the code? That's the easy part now. The massive challenge we face in evaluation is the under-specifications gap. When a user prompts, make the dashboard load faster, there's no rigid test spec for that. Our evaluation framework has to determine if the agent actually reconstructed the user's unstated intent while adhering to the project's overall architecture.
Evaluating a vibe-coded agent breaks down into two distinct areas, the user-facing outside and the internal inside. The outside is what the developer experiences directly. Did the app work? How much did it cost? The inside is the invisible trajectory the agent actually took to get there. And cutting across all of this horizontally is safety and responsible AI.
Instead of a simple checklist, think of this as a holistic health check across 7 key dimensions. On the user-facing side, the ultimate goal is intent satisfaction. Did it build what you actually meant? We check functional correctness, sure, but that's just the floor. An agent can easily delete a failing test to make a pipeline look green. So we also measure visual correctness for UI, plus cost and efficiency. Internally, we evaluate code conventions to ensure it matched your team's style, trajectory quality to see if it read the right files in the right order, and self-repair behavior to observe exactly how it handles a failing build.
To measure these dimensions, you really can't rely on just one method. Automated testing's cheap, but it's easily gamed. Standardized benchmarks like SW Bench are great for baseline cognitive calibration, but honestly, agents often overfit to them. To evaluate the nuance of vibe coding, you need LLM as a judge to score stylistic choices. Crucially, you absolutely must use trajectory inspection. By utilizing trace replay tools fed by OpenTelemetry, you can expose the agent's internal logic, looking step by step at its reasoning spans and tool invocations to judge whether it made sound architectural decisions.
And hey, if your agent is generating front-end code, you have to completely rethink evaluation. Looking at a code diff is not going to tell you if a button state is visually broken or if the color contrast fails accessibility standards. You must use multimodal evaluation. This means combining Playwright scripts to actually interact with a rendered web application, take screenshots, and pass those images to a multimodal judge to evaluate the actual visual UI artifact against the original user spec. You literally have to judge what the user actually sees.
As we wrap up today's explainer, I want to leave you with this provocative question to chew on. Have you built a secure harness, or are you just blindly trusting the engine? Transitioning to agentic engineering is an incredible leap forward in developer velocity for sure, but it requires completely abandoning implicit trust. You must enforce continuous effective trust through zero ambient authority, deploy AI-driven SecOps, and rigorously evaluate both the intent and the trajectory of your agents. The teams that thrive won't be the ones that just generate the most code, they'll be the ones that master the discipline of securing and verifying it. Thanks for joining me here on Camel Leap, and I'll catch you in the next one.